Now, let's look at mechanical, electrical, and plumbing takeoffs. Now, for a lot of you civil engineers out there, this is probably going to be the most confusing section because you're not familiar with looking at mechanical drawings, electrical drawings, or hydraulic drawings. But it's much simpler than you're probably originally thinking, so don't stress too much. Just basically, we'll go through, understand the different types of drawings, what's shown on the drawings, and then we'll look at the key quantities that you need to be able to measure. So in this section on MEP takeoffs, we're going to talk about the different MEP drawings and specifications, the different types of quantities you'll be measuring, and like with the other sections, we'll go through a worked example of how to measure these key quantities. Let's start with looking at an example drawing package of mechanical, electrical, and plumbing, and we'll go through all the different types of drawings and what they're representing and what they're showing. All right. Now we're going to look at some example mechanical, electrical, and plumbing drawings. And you'll notice when looking at these sorts of drawings, whether they're mechanical, whether they're electrical, they come in two categories. You've got schematics and you've got layouts. So what a schematic tells us is basically how everything's connected. They're like a wiring diagram. So this really simple example shows the incoming supply from the street, the house distribution panel, and then the services that are connected to the distribution panel. So there's the lighting, the hot water, the washing machine and hot water, the plugs, and the kitchen. Now, this is just a really basic example of a single electrical single line diagram or a schematic. Then as well, you'll need to read this information in parallel with a layout drawing. Now, what a layout drawing tells you is physically where everything is. So this is an example of an electrical layout that shows you where the lights are, the recessed lights, the wall mounted lights, where the fan is, and the power outlets. And there's also data cabling for a telephone outlet and the switches. So when we're talking about electrical drawings, there'll be a schematic that shows you the interconnection of all the services, and there'll be a layout. Same with a plumbing drawing. So this is an example plumbing schematic for, this is more complicated than a simple house or building, but there's a chiller, a membrane, an air vacuum. But basically, even if we don't understand what all this stuff does, they're all separate pieces of equipment, and this diagram is showing how they're interconnected. Then we've got our plumbing layout that shows where the pipes run, the different colors of the pipes would represent the different services. So red would be hot water, blue would be drinking water, and purple would be drainage. We just look really simply, just tells us where everything is and where everything connects. And then same with the mechanical. We've got a schematic drawing that shows how everything's connected. And then we've just got a simple layout drawing that shows the actual position of ducts, of the fans, and where the ventilation points are. So for our sample set of design drawings, let's look at how the services information is shown for our example garage project. We've got, firstly, if we look at the architectural layouts, you can see there's a water tank slab with a rainwater tank. There's a bathroom, so there's obviously going to be water running to the bathroom. And then within the indoor areas, we're obviously going to need lighting and power. So if we look, this is the electrical drawing. You can see that the schematic information is represented as a table. So it shows the information about the distribution board, the information about the different circuits, and then it also shows on each circuit what services are connected. So each of these represents a light, each of these represents a power point. And then if we look at this, we've got an internal building layout and an external building layout. So this is the power to there's a electric gate. So this is the power to the gate and the earthing. This shows as well that that's the power to the gate motor, that's the meter and the street supply and the earthing point to the grid electric supply, the distribution board, and on the layout drawing you can see electric, you can see what an underground duct, there's roofing duct, and there's duct for the electric door. So basically, if you look at this layout diagram, you can see the position of all the lights and the sockets, and then how they all connect back to the distribution board. So you can see these are connected by an underground duct, these are connected by a roof duct, and then there's an underground duct out to the rainwater tank pump. It also just shows you, if you go back, you can see which circuit these sit on in the distribution board. So if we think of this as a schematic, while this isn't represented as a single line diagram, you could imagine that each of these represents a circuit and it shows all the services connected to it, but it's just represented in a table rather than a single line diagram. Now, if we go to find our hydraulics drawings, for example, this is an internal layout of the building. It shows the different valve types, the connections to the shower, the different services running. So you can see the actual pipework. So green represents rainwater, so drainage from the pipes. Pink represents the sewer, and blue represents the drinkable water. So if we find, there's another layout drawing that shows the sewage. So there's a floor drain, connection to the pipe, and external layout. So you can see the metering point from the street, the connection of the drinking water. Pink represents the sewer, and then we've also got the rainwater drainage to the street, the connections from the roof. So there'd be roof plumbing in a box gutter and collects the water that runs to the tanks. So you can see in these drawings that you've just got a simple layout that shows the orientation and position of where everything is, the different types of water services, and how all the drainage is connected. Now we've understood how to read mechanical, electrical, and plumbing drawings, let's now look at what are the key quantities you're going to need to measure to accurately estimate, schedule, or procure. We'll look at each of these key quantities based on the different trades. So we'll look at mechanical systems, electrical systems, plumbing systems, and then also fire protection systems. So fire protection systems generally sometimes fall under plumbing, but they are a big part of any building project. For mechanical systems, our key quantities will be our ductwork, our HVAC units, and any room fittings. And so for any ductwork and pipes, we'll use linear measurement. So we'll simply measure how long they are, all the different types of ductwork and sizes. And then for the fixtures and HVAC units, we'll do a count measurement. So we'll simply count up how many of each of the different types there are. And then we'll also note down all the different material types and specifications, so we correctly categorize our measurements and our counts. Electrical systems, we want to know the length of wiring, conduits, the number of outlets, the number of switches, and the number of light fixtures. And so same with the mechanical, for any of our cabling and conduits, we'll need to perform a linear measurement of all the different types and sizes. And then for our light fittings and outlets and distribution boards, will simply perform a count measurement. It's also important to consider data cabling versus electrical cabling, and also the different sizes and types of distribution boards and panels. But that should all be shown clearly in the drawings and specifications. For our plumbing systems, we'll need to know the different length of pipes, the number of fittings, the number of fixtures, and so things like sinks, toilets, and showers, and also hot water units. And we need to consider the different types of services. So plumbing, there's obviously potable water, which is drinkable water, there's drainage, there's sewerage, there's hot water. So we need to consider all these different types of plumbing services. And same with the mechanical and electrical. For any pipe work, we'll just simply perform a linear measurement to record the different quantities and types. And then for our fixtures, we'll perform a count measurement. And finally, for our fire protection, we'll need to count the number of sprinkler heads, the length of piping, the number of valves, the number of fire extinguishers, and the number of alarms. And we should consider that any of the fire systems will be broken down into either the wet fire, which is the reticulation of the sprinklers, or any dry fire, which is things like fire alarms or fire extinguishers. And same with the others, we'll perform a linear measurement for all the piping and plumbing, and then simply a count measurement for any of the fixtures. Now, let's go on to our worked example of measuring all of these key quantities. To complete our quantity takeoff, we'll review the electrical drawings and the plumbing drawings, and we want to measure all of the key quantities. We just open an Excel document to set this up. We'll say for electrical, we want distribution board, bunch of light fittings, we get power outlets, then we want we'll call it circuit cabling, the underground ducts, that'll be a length,
kind of, it has, and the roof duct.
That pretty much all the key quantities that we want to go through the drawings and we want to calculate.
So to begin with, we'll go back to that electrical layout
and let's just make sure we've got all these.
Shall put down
metering point.
Points.
Let's just double check that you've got everything and cabling, sorry.
But that
start and we'll record quantity number. So there's one distribution board. Next, we want to get all the different types of light fittings. But remember, they've given us all this information ready to take from here. So we don't actually have to go calculate it individually. So we'll just set it light fittings. We'll break those down into two types. What's the terminology? We call it a ceiling light and a wall light. Yeah, if they didn't give you this information in the table, it'd be easy just to go through the drawings and count them up. Since we've already got it in the table, we'll just take it from here. So there's 5 of the ceiling lights, 2 of the wall lights.
I performed it.
Then for the power outlets, they're just wall double sockets. Rename that for our board sockets. The wall double sockets, there's... Sorry, we should get switches as well. I missed that. So 5 switches, which would come under lighting. And then for the wall double sockets, there's 5s. I already had cabling there. So let's just call this cabling. And what are the different types of cabling? AWG 14, AWG 12, and then we'll call it the mains cabling. Now, this drawing has, again, I don't think it's got a scale on it, but we know the length of building. So I'll just quickly calibrate. So how is the building? Building is 11059 plus 3.88.
Yeah.
14.147. So we know this length. Tools, set scale, custom. How long is it?
14.1%.
So that's the internal lengths. Then we have to have the external lengths as well. So we can get those from another drawing. We know the mains cabling is going to run from that corner to that corner. So you can just simply go to this drawing. With the same foot node.
Let's have it sell it up. I can cut this off.
It's 36.9 meters. And when we're doing cabling, we want to allow generally we will allow 2 meters at either end for terminations. So we go equals 2 meters either end for terminations. So we go equals and 5% for wastage. Plus 2 by 2 times 1.05. So it would be 43.05 meters. The mains cabling. What other external cabling is there? Then we'll just do this one circuit by circuit. So C1, C2, same.
I tend to be a front.
So and C7. C7 is going to be $36 meters.
The ball. The frame.
So let's work out. So C, I'll just put the actual lengths here and we can apply termination lengths to it after. So it'll be equals this plus 4, because you've got terminations at both lengths, times 1.05. So that 5% wastage. And then we'll get the actual length. So C1, that right to that, to 13 meters plus to that switch. So for C1, that gives us a total length of 13 plus 7.5 plus 5.5. 17 plus 7.5 plus 5.5. C2. The C2. C2 goes, look, okay. Goes through here, 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 here. That's 11 meters. C3 is going to be here. The tanks.
16 meters C4. Next for C4, which is trying C4. Oh. C4 is the garage door engine. So it's that one. Which they've labeled it C5. I think it's wrong. 7.9. So go at 8 meters. And then C5 is, his labels aren't correct, which is a little bit confusing, but at the end of the day, it doesn't matter as long as the quantities are correct. In 2 meters for that. 2 meters, and we'll just apply the same formula. Sorry, that's for C6, and C6 is the power to
So,
C6 was C7, same thing. A bit confusing because these labels are wrong. But
we'll just call that 3.
5 meters. Delete those, and then we've got our lengths of the different cablings. Now, could go and do all these duct lengths in detail, but I'll skip that because the principle is the exact same. We're just measuring lengths. So just also fill out that we've got 1 metering point and 2 earthing points. And that's our electrical quantities. Then for our hydraulics quantities, the principles are actually exactly the same. We've just got to go through the drawings, count up the number of different floor drains, fixtures, bends, lengths, and add them into a bill of materials. So the takeoff principle is exactly the same. It's going to involve measuring all these lengths, counting the number of valves, counting the number of fixtures, and adding them to a table. So I won't go through and do that for the hydraulics. That's something I'll leave for you to do. And yeah, the principles are all exactly the same. It's just measuring lengths, calculating quantities.